All right, last section in chapter 8 is 8.6, at least that we're going to do, and it is partial fraction decomposition. So this is an absolute doozy of a section, but we've learned everything we've learned to this point. We'll hopefully make it so it's not super, super bad. But what I want you to think about is just think way back, and let's say that we were going to add two fractions. So let's say we had to add x over x plus 3 plus 4 over x plus 2. Okay. So in order to do this, we would have to get a common denominator. So this guy would need an x plus 2, and this guy would need an x plus 3. But if we do that, it means this guy up here needs an x plus 2, and it means this guy up here needs an x plus 3, right? Common denominator, okay? So now we can work this through and say that we have x squared plus 2x plus 4x plus 12. And that will all be over x plus 2 over x plus 3. Then simplify the top, and we end up with x squared plus 6x plus 12 all over x plus 2 over x plus 3. All right, so remembering, common denominators and stuff isn't such a big, not such a big deal. But what we're gonna do now is we're gonna work the problem backwards. So we're gonna go, and we're gonna end up back at the beginning. So now I'm gonna give you this, and I'm gonna ask you to find the two fractions that we added together in order to get to this. Now, going backwards, not quite so much fun as going forwards. So it requires common denominators, it requires matrices, it requires a bunch of work. So first, let's look at this. We won't jump right into a problem, we'll just start it off. So let's say that we were given, it really doesn't matter about the top right now, so we'll just say 72, and we had x plus 3 and x plus 4 on the bottom. Okay, so we have our common denominator already, and what we're doing is we're pulling it apart. Now, when we pull it apart, we don't necessarily know what's going to go on the top. That's what we're looking for. But we know that if we were adding these two fractions together in the beginning, that one of them probably had a denominator of x plus 3, and the other one had a denominator of x plus 4, right? X plus 3 and x plus 4. Now, we are required to figure out what the heck goes on top there. So let's look at this though. What I want you to notice is if you've got a factor that looks like x plus or minus c, just the very basic binomial factor, then what goes on the top of each fraction is going to be an a or a b, okay? And we use b because it'll be different than a. So we just put a single capital letter is normally the way that we notate this, okay? But that's what it's gonna look like. Now, let's look at another one, and I wanna show you something a little bit different. Let's say this one is 8 over x minus 1 x plus 4 squared. Now, at first glance, you might think that this one is, again, just two fractions split up. But because of that squared going on there, what this one looks like is we're going to take a over the x minus 1. Okay? That would have been one of our denominators. And then we have to make the possibility of all the different denominators. So we're going to take b over x plus 4, because that could have possibly been one of our denominators if we were pulling this apart. But then we need to go c over, and we don't just do another x plus 4 because of that, we go x plus 4 squared. So these are the three different denominators that you could get. Now, if this had been a 3, then we would have needed a d over x plus 4 to the third power. Okay? So that is another type of problem that you could come up with. Or one more here just for the heck of it, so you've seen them all. Let's say we had 64 over x minus 7, and then 4x squared minus 13, okay, for lack of something better. Now, that guy definitely does not factor, so notice how it is not just a nice straightforward binomial. It is got an x squared in there, so this one is going to require something different from us. So the first one will still be a over x minus 7, but the second one is going to require up top not just a b, but a bx plus c, all over 4x squared minus 13. So if you have one that doesn't factor, so you have an x squared and it doesn't factor a quadratic, what needs to go on the top of that fraction is bx plus c. And the idea is we're making the possibility of any situation that we might possibly have. So these are the different ways that we're gonna have to set up our problem. Now, that is only just the setup. That's not even the doing of the problem. So we're gonna do 3 examples here so that you can see one example of each, okay? And we'll probably do this in 3 parts. So I'll do the first example and take a break, second example, just like we normally do. Okay, so I'm gonna erase this. Hopefully you have it written down. And let's start. Okay, so again, the idea behind here is pulling the fractions apart, working backwards. Okay, so we're going backwards here. So in this first example, the fraction or the end result that they give us looks like this: x plus 5 over 2x squared minus x minus 1. Okay, so you have to assume this is the end result. The problem has already been added or subtracted together. This is the end result. So one unnice thing about this one compared to the ones we wrote up here is that they haven't factored this yet. So the first thing to do if it's not factored is to factor. Now I know that it's gonna have a 1 on either end, and one of these is gonna have to have a 2, so a 2x and an x. We just need to figure out which one is negative and which one is positive, so we get a negative 1. So if this one is negative, so -2 plus 1 will give us that -1 in the middle. So now we know that we are going to have 2 fractions, because these are both nice, just little binomials. So we can rewrite this as a over 2x plus 1. Plus b over x minus 1. Okay, so we pull it apart. This is the way that the problem would have looked at the very beginning. We just need to figure out what the heck a and b are. So the way that we're going to do this is we're going to think back to how would you, if we knew what a and b were, how would you do this problem? So we would get a common denominator, wouldn't we? So we would, Max, can you take him out of there and do something with him? So we would multiply this guy by an x minus 1, which means this gets an x minus 1. And we would multiply this guy by a 2x plus 1, which means this guy gets a 2x plus 1. Okay, so what we've got now is ax minus a plus 2bx plus b. Everybody agree? And on the bottom, we would have our 2x plus 1 and our x minus 1. And I don't know why I went to blue and then didn't come back. But anyway, okay. So this is what we look for. Now, we can forget about the bottom of the denominator. We've taken care of the bottom of the denominator. Now we are going to focus on the top. And what we're going to do is we're going to arrange this with the x's together and just the constants or the letters together. So notice how this guy and this guy. So we could write that as ax plus 2bx. Okay, everybody agree? that's what those, if we just combine them together. And now, I'm gonna switch this up a little bit. I'm not gonna write it horizontally, I'm gonna write it vertically, because we're kind of getting ourselves ready for the next step. When we look at these, we would have minus A and then plus B. Okay. All right, now if we put that all together, it would be the top of that fraction. Okay, so now we're done with this, we're done with that. That was just a side step. Now we're going to come back over here and we come to the top of the fraction. Now we know that it's gonna have ax plus 2bx. That's what the top of this looks like. And we know that the original problem had a single x. So we know that this is gonna equal, or needs to equal, just x. And we know that constant-wise, without any variables, we have negative a plus b, okay? But we know that that needs to be a 5. Okay, so we know what we're looking for here. We want a 1x and we want a 5. So we set it up so that the x's equal x and the constants equal 5. I know it seems a little weird. This is the weird step. Now what we're going to do is we're going to drop the x's and the a's and b's, and we're going to make a a matrix. But we can't put A in our matrix, we can only put a letter or a number. So this is like a 1A, isn't it? So we're gonna go 1, leave off the AX, plus 2, leave off the BX, and then here's our line, equals 1x, so we're gonna put 1. Now, down below, we're gonna have negative 1, leave off the A, plus 1, leave off the B, equals 5. So there is our matrix. And this column represents the A's, and this column represents the B's. So if we can put that in our calculator and figure out what that's equal to, or if you wanted to do it by hand, you could have, but we're into the point of using our calculator now, which I have left in my backpack, so hold on. But if you want to use your calculator, remember that we're going to RREF, and we can figure out what the answer is. So we're going to go RREF, but first make sure you put your matrix in there. So edit. And we're looking at a 2 by 3. So 2, enter, 3, enter. 1, 2, 1, negative 1, 1, 5. Make sure you look at it, make sure everything looks good. Second quit to get out of there. Then back to matrix, over to math. Down, 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 down to the RREF. Tell it what matrix you want. And I end up with, I'm just gonna use a little arrow here, 1, 0, negative 3, and 0, 1, 2. Now remember, this represents the A's and this represents the B's. So this is like saying that A is equal to negative 3 and B is equal to 2. So guess what we get to do? We get to come up here and we get to plug our A and our B in on top of our fractions. So we say negative 3 over 2x plus 1 plus 2 over x minus 1. And now we've got it. So if you want to find common denominators and add together, you will end up with this. Or if you start with this and you want to pull the fractions apart, you will end up with this. So we have done the problem backwards, okay? Real pain in the butt, I appreciate that. But the truth is that when you get to do calculus on these really big fractions, and they're going to get bigger than this, just give me a minute to get you to that point. But when you do these on really big fractions, the calculus is a disaster. So if you can break up the fractions into littler pieces, it's worth the time to do this than it is to do the calculus on the whole big problem. So it's in your best interest. Okay, so let me stop here, and then we will come back and do another one so you can see another one.